Hello, Algebra, and welcome to your video on solving quadratic equations using square roots. I apologize for being absent today, but here is your video. Okay, so first off, let's talk about how to simplify radical expressions. So some important concepts to understand, right? So when we're taking a square root, it is this like check mark looking thing. There's this space right here called an index. A square root means that its index is 2, right? So there's a hidden 2 there. But because we use square root so often, we never put that 2 there, right? So notice I have the square root of x times x, right? Well, x times x is x squared. If you take the square root of x squared, what happens is that the square root and the squared will cancel, and it releases the base of the exponent, the x in this case, from the square root, and you get an answer without a radical, right? So we call these inverses, right? These guys are inverses of each other, just like addition and subtraction are, just like multiplication and division are. So again, they undo each other, and that releases the variable. Now, you don't always get rid of the thing. It's called the radicand, but the thing inside the radical. So in our second example here, notice we have the square root of x squared times y. Well, what we can do is we can break this apart into two separate square roots. So we can do the square root of x squared times the square root of y, right? This is called the product rule. And again, it's called the product rule because you can break the radical apart at the product, right? The dot, the symbol. So now here, the square root of x squared will cancel, and the x will come out, as you can see here. It's out in front of the square root. But because the y is not squared, it is locked and must stay in the square root. And now you have an answer that has something on the outside of the square root and something on the inside. Okay, so that can happen. And that's more likely to happen. All right, so let's take a look at simplifying some square roots, some radical expressions. Okay, so first one, 54. So we are going to break down 54 into its prime numbers, okay? So if we look at 54, I know that 2 will go into 54. Again, when I say primes, so the prime numbers, 2, 3, 5, 7, and so on, right? Those numbers. So I always start with the smallest number, so 2. So I would just use Desmos in my brain. 2 goes into 54 27 times. 2 is prime, so I'm going to circle 2. Now, let's break down 27. 2 does not go into 27, but 3 does. 3 goes into 27, and again, you can use Desmos for your brain 9 times. 3 is prime. 9 break down into 3 times 3. And both of them are prime, and we're done. Once all of your factors are prime, you are done. So what this is 1, 2, and 3 3s. Well, we want squareds because, again, this square root has a imaginary squared there. So I'm going to group these two 3's using a squared. So I'm going to do 2 times 3 squared times 3. So I've taken these two 3's and grouped them. So now I'm going to rewrite the square root of 54 as these 3 separate square roots. So the square root of 2 times the square root of 3 squared times the square root of 3. 3 separate square roots using that product rule. And now the only thing that's going to cancel is this middle 3. The squared and the square root will cancel, and this 3 will come out. 3. But now since the 2 and the 3 are still locked in the square root, go ahead and multiply them out together. And 3 and 2 make 6. And there is your final answer right here. 3 square root of 6. Okay, next one, 98. Okay, so again, I want to break it down to its prime numbers. So 2 goes into 98, and again, use a calculator or your brain, 49. 2 is prime. 49 is not divisible by 2. It's not divisible by 3. It's not divisible by 5, but it is divisible by 7. And it's actually 7 and 7. Both 7s are prime, and there we go. I stop. So 99 is 2 times 7 times 7. Well, we can group those two 7's and make it a 7 squared. So 2 times 7 squared. And now I'm going to rewrite it as the square root of 2 times the square root of 7 squared. Because the 7 squared is underneath the square root, they cancel. The 7 comes out. This square root of 2 is going to be locked inside the square root, so you need to write it with a square root. And there we go, 7 square root of 2. All right, last but not least, 125. So I'm going to break it down. 2 does not go into 125. 3 does not go into 125. 5 goes into 125. And 5 goes into 125 25 times. 5 is prime. So now look at 25. I can, again, divide 25 by 5, and I get 5. So 125 is just 3 5s. So 5 times 5 times 5. Again, let's group them in groups of 2. So I do have one group of 2, so make that a 5 squared with a measly old 5 left over. So I'm going to rewrite it as the square root of 5 squared times the square root of 5. This square root cancels that squared, and this 5 comes out of the square root, but this 5 must stay inside, and that leaves you with the square root of 5. And there's your answer, 5 square root of 5. So this is a skill, simplifying radicals. Again, you're really not changing the problem, the answer, you're just changing what it looks like. Perfect. Okay, next slide here. Okay, so now, what about solving equations, right? How do we solve equations using these square roots? So you'll be given an equation like this. And again, I put 0 here, but sometimes this can be a number. But notice, I used ax squared plus c to kind of follow that same, like ax squared plus bx plus c. But notice here, there's no bx, right? There's no bx term. So because there's no bx, we're not going to use factoring. We're going to use this method of using square roots. So step 1, we need to isolate the x squared. So in this problem, we need to get the x squared all by itself. So usually that first step involves an addition and a subtraction, or a subtraction. And then the second step is going to typically be division, but it could also be multiplication if there's a fraction involved. Second step, the key step. We're going to take the square root of both sides. So notice I take the square root here and the square root here. Notice right here, on the side without the x, I put a plus or minus sign. If you recall from the graph of these quadratics, typically it's going to go through the x-axis twice, so there's typically 2 answers. That's where we get the 2 answers from because of the plus or minus. So 2 answers. And again, you could split this into x equals the positive square root of x, or square root, and x equals the negative square root. And those would be your 2 answers. And then lastly, you'll either simplify if it asks you to simplify the radical, or you'll approximate it using the calculator and just type it in. Perfect. So there's the first video. I'm going to stop there because this is midway, and I'll make a second video for the second half of the notes.